Hello everyone. Previously we talked about how stacks worked, so today we're going to actually see the code of a stack, or a variation of the code. There's actually several ways you can write it. This is just my kind of interpretation of it. We'll of course see some other ways to do it. And of course, in the program you can actually just import the built-in stacks and queues and whatever other data structure we see. The downside to that is it doesn't tell you how it works. So we're going to focus on how this works. So what we got here is a stack class. And if you remember previously, a stack is essentially just like a stack of books, a stack of pancakes, a stack of anything. Whatever you put on gets put onto it, and then the next thing gets put on top of that, and the next thing gets put on top of that. And when I take something off, it's always the top item that comes off. The top item that comes off. It has to be kind of done in that order. So I've already got the code written out. So what I want you to do is copy what I've got here. Apparently I have two into pushes. There we go. Let's fix that. There we go. So I'm going to leave this up for a second. I'll give you, you can pause the video, whatever you need to do. Go ahead and copy what you see here. I'll pull it down for the bottom. And that's it. All right. Once you got it copied, let's go to it. So we start off with our constructor, well, our stack class. We have our constructor, which always starts with this init self, and we're going to give it the maximum size of the stack. Now, I could make this kind of unambiguous, where it could be whatever size it needs to be. It could grow as big as I wanted it to. But in this version, we're setting a size that's a maximum, that's allowed. So we won't go beyond that. So we start off with our basic variables. I have some print statements in here so we can kind of see what's happening when it's happening. We set the max size for this thing. Any of these max size just means it's a variable on this stack class here. This is a local variable that I'm passing, so I'm assigning whatever number I gave it to this variables, or not this variables, this objects variable here. So that's the maximum size. This is the current size, however many items are on there. This is the top location of the stack. And this right here is the stack itself. It's just an empty list. I called it list. That's the name of it. And it's just empty. Now, the nice thing about Python is this list can be anything from strings to, integers to doubles. In Java, C++, C#, and other languages, I have to define what specific thing this is, whether it's an integer, whether it's, a string or whatever. For this example, we're just going to go with integers, just your basic numbers. All right, so that's what we got for our constructor. We'll move down. Our first operation is the push operation. So our push operation, I guess I can line those up a little better here. Let's see. There we go. So that looks a little bit more organized. So a push function pushes an item onto the stack. So I will print push, and item is what I call the thing that's getting put on there. If the size is already the max size, that means the stack is full. I just print that message and don't put it on the stack. Else, that means the stack still has room. It could be empty, it doesn't really matter. We go ahead and we put it on the stack. So top is -1. When I increase it by 1, that puts it in slot 0 of my list here. So all lists go from 0, 1, 2, 3, 4 in that number. Now the size is set for 0, it goes to 1, and that's just how many items are on here. So, and then of course I append to that list. Now I could put it at a specific location or something, but with Python, append just adds it to the end of the list. And since this is a stack, I can just, remove it from the end of the list and add it to the end of the list. I don't have to do anything kind of extra. That's probably more than enough there. So that puts it on my stack. If it's full, it won't put it. If it's not full, it'll put it on top. Now pop, a little bit more stuff here, but not by much, as you can see. Well, actually, about the same. We go through here, and this takes the top thing off. Now, in order to do that, one, the stack has to be full, has to have something on it. So the first check is it empty? If it's not, then if it is empty, we say it's empty, we can't take anything off. If it isn't empty, then I use this command, delete list, and this actually deletes a specific location in my list. So the del function and this self.top would be, 0 at the first time. I would remove the 0 location in that list. So I have a list 0, 1, 2, 3, 4, and this would remove, whatever's at the top. So 0 is going to be a top, then it'll be 1, 2, 3, 4, and if I was full and I deleted, this would delete the 4th slot. And then I would, of course, subtract those numbers. The size would go down, the top would go down, and I would remove it. So this removes that item from my stack. I have a little print method here that displays the stack. I have a little variable count that is set to the size. So if the size is 5, I've got it set to 4. And that means I'll go 0, 1, 2, 3, 4. Now I could take that off and make this greater than. It ends up being the same, it doesn't really matter. Just know this is going to go through however big the list is. We're going to count starting at 4, or wherever the highest location of the stack is, and going backwards. So it'll be like 4, 3, 2, 1, 0, and then it'll stop. And all I'm doing is simply just printing whatever item is in that location as we go back. Now I've got a couple of things put in here already. So I've got a little pop operation. I'm going to leave that undone while we run this. We have a stack of 5, so it has 5 items that can go on it. I can push a couple of things on it, and of course I can take things off of it. So let's run this and see how that works. Run. Here we go. So I pushed a 10, and then I pushed a 30, so the 30 should be on top. Now if I pop that 30, I only have 10 on the stack. Now if I push a whole bunch of things on here, let's just add several here just to see. We'll go with 40, 50, 60, 70. All right, so I've got 10, 30, 20, 40, 50, 60, 70, or whatever. I'm going to undo the pop. We'll run and see what it says. So it pushes 10, 30, 40, 50, 60, 70. Now, when it tries to push the 70, notice it says pushing 70, but then it says stack is full. Well, that's because there's 5 things on it already. So it can't put that 70 on there. So when we print 10, 30, 40, 50, 60, just like that. So if I try to pop something, after all that, it should take off the 60. So I have 50, 40, 30, 10. So that's what my stack looks like at the end. And that's roughly how the stack works and how it runs. This is, again, a somewhat simplistic version of it. So there will be other versions. And there's also the built-in versions we can kind of look at. They all work basically the same way, but there are some slight differences in how each of these little operations are written. But we'll see that in due course. If you have any questions or any issues, just let me know.